But Tesla's most anticipated vehicle isn't the Cybertruck or the next-generation Roadster. It's the Model 2, a compact electric car that could finally make EVs accessible to everyday Americans. With a target price hovering around $11,595 after incentives, this vehicle represents Elon Musk's boldest bet yet, that Tesla can revolutionize not just what electric cars can do, but who can afford them. But how exactly does Tesla plan to build a capable EV at this price point without sacrificing the performance, safety, and technology the brand is known for? Today, we're breaking down Tesla's revolutionary production strategy, the game-changing technologies making this possible, and what it means for millions of drivers waiting for an affordable electric vehicle. The secret code that confirms Model 2 is real. Just announced 3 days ago, Tesla officially assigned an internal development code to their long-awaited budget electric vehicle, NV91. For those unfamiliar with Tesla's internal naming conventions, this might seem like just another alphanumeric designation. But for industry insiders and Tesla watchers, this code reveals something significant. The Model 2 has moved beyond concept stage and into active engineering development. In Tesla's internal coding system, NV typically stands for new vehicle, followed by a sequential number representing the specific project. The original code NV9 was used for Tesla's affordable car project, first announced in 2024. Now, in late 2025, the appearance of NV91 and its companion code NV93 suggests these are upgraded versions evolved from that original platform. According to sources close to Tesla's headquarters, NV91 represents the Model 2 itself, a compact, mass-market vehicle designed for everyday drivers. Meanwhile, NV93 is believed to be the robo-taxi variant, focused specifically on autonomous ride-hailing operations. The fact that Tesla has assigned a specific internal project code indicates the Model 2 has left the whiteboard stage entirely. Since late September, numerous social media users have posted sightings of mysterious test vehicles running on California roads. The dimensions measured beneath the black camouflage tarps suggest these prototypes are approximately 15 to 20% shorter than the Model 3, with hatchback design lines completely unprecedented in Tesla's current lineup. The revolutionary Giga casting process. So how exactly does Tesla plan to bring the Model 2's price down to levels that make it competitive with used gas-powered cars? The answer lies in a revolutionary manufacturing approach called Giga casting, and it's happening right now at Giga Factory, Texas. Forget traditional assembly lines with nearly 30,000 individual parts. At Giga Texas, building the entire body structure of the Model 2 requires just 3 massive aluminum castings produced by 50,000-ton Giga Press machines: the front section, the rear section, and the structural battery pack. But why does this single manufacturing innovation allow Tesla to slash approximately $7,000 from each Model 2's production cost? First, the number of parts drops dramatically. The Model 2's body structure slashes that part count by approximately 70 times, down to just 423 components total. This alone saves roughly $2,000 per vehicle in material costs, logistics expenses, and inventory management. But the savings multiply when you consider what fewer parts actually mean for the assembly process. When these massive 3-piece castings come together in the Model 2, they require only 16 precision welds, supplemented with aerospace-grade adhesive rated at 40 megapascals. Compare this to a Chevrolet Equinox EV or Ford Mustang Mach-E, which each have more than 5,000 welds throughout their body structures. On the Model 2, that number drops by over 91%, down to only about 300 total welds. This dramatic reduction in welding requirements creates another massive cost savings: labor. Tesla doesn't need 40 to 50 workers on the production line to handle welding operations and quality inspection checkpoints. This saves approximately $1,500 in direct labor costs per vehicle. The robots and automated inspection systems don't need to run continuously either, reducing energy consumption by roughly 3 kilowatt-hours per vehicle. Over a full year of Model 2 production at scale, that represents $50,000 in energy cost savings. Elon Musk has publicly promised a starting price under $25,000 for the Model 2 before any government incentives. But with these manufacturing innovations, production costs could potentially drop enough to bring the base price down to approximately $19,000 before federal tax credits and state incentives that could push the effective price for many buyers below $12,000. Strength and durability without compromise. Now, you might be thinking, sure, fewer parts and lower costs sound great, but doesn't that mean buyers are getting a cheaper, flimsier vehicle? Not even close. The Model 2's frame is cast from aerospace-grade 6061 T6 aluminum alloy, the same material used in aircraft construction. This alloy is heat-treated to achieve a tensile strength of 400 megapascals, meaning it can withstand enormous forces without deforming. A single solid casting of this material spreads impact forces evenly throughout the structure, completely eliminating the stress concentration points you'd find in traditional welded frames. That's why Tesla engineers estimate the Model 2 chassis can last up to 30 years with proper maintenance. And you won't be throwing away thousands of dollars for structural weld repairs that plague traditional vehicles as they age. With the structural battery pack forming a one-piece aluminum frame, the Model 2's torsional rigidity is projected to be 30% higher than the current Model 3. Even better, the Model 2 could end up being Tesla's lightest vehicle frame ever at just 120 kilograms, compared to the 270 to 320 kilograms of current Tesla models. That massive weight reduction means the car requires significantly less energy to move, translating directly into improved efficiency and range. With an LFP battery pack similar to the one used in the current Model Y, the Model 2's range could increase by approximately 15%. That could push the range from roughly 267 miles up to nearly 307 miles per charge. More than enough for most daily driving needs and even weekend road trips without range anxiety. Production. Speed that defies belief. Manufacturing efficiency doesn't just reduce costs. It determines how quickly Tesla can get vehicles into customers' driveways. After seeing Tesla's sales fall 13% in the first 7 months of 2025, while BYD's sub-$10,000 models dominated international markets, launching a truly affordable vehicle is central to Elon Musk's strategy to reclaim market share. Consider what Tesla already has operational at Giga Texas right now, a facility cranking out vehicles more than 8.4 times faster than Gigafactory Shanghai could manage just 3 years ago. The new Model Y Juniper builds at a rate of one complete vehicle every 18 seconds. But the Model 2 production process operates on an entirely different level. When molten aluminum alloy heated to 700 degrees Celsius is poured into the 50,000-ton Giga press machine, it's injected at 34 megapascals of pressure to instantly fill the massive mold cavity in just 0.95 seconds. A sophisticated cooling system using 5 degrees Celsius air and 300 internal water channels flowing at 500 liters per minute solidifies the entire casting block in only 1.5 seconds. In Tesla's revolutionary unboxed manufacturing process, 3 Model 2 castings are produced simultaneously, taking just 2.45 seconds total before they snap fit together into a complete vehicle frame structure in the next 2.25 seconds. Each complete Model 2 chassis takes exactly 4.7 seconds from molten aluminum to finished frame. And in this highly automated process, downtime approaches zero thanks to Starlink satellite internet integrated directly into the factory. When Ford or Hyundai detects a welding error, it typically takes 2 hours to fix. But at Giga Texas, robots and sensors communicate instantly with latency of just 20 to 30 milliseconds. Tesla's AI-powered control system can process millions of sensor signals in real time, detect errors as they occur, and automatically correct them during production. Global production strategy. Tesla isn't putting all its manufacturing eggs in one basket. The company is strategically deploying Model 2 production across 3 major facilities. Gigafactory Texas will handle approximately 50% of total global Model 2 output, with initial Texas production projected to reach 1 million vehicles per year. Gigafactory Shanghai will produce for the Asia-Pacific market, accounting for approximately 30% of global production, serving China, India, and the ASEAN region. Finally, Gigafactory Berlin will focus on European market production, expected to account for 20% of total output. Battery technology options. One of the most interesting aspects of the Model 2 program is Tesla's approach to battery technology. Instead of forcing all customers into a single battery type, Tesla is reportedly developing 3 distinct options. The first is an improved LFP battery with energy density of 200 to 250 watt-hours per kilogram, allowing 320 to 350 miles of range. The second option, sodium-ion batteries, offers 300 to 320 watt-hours per kilogram with incredibly low production cost of less than $30 per kilowatt-hour, approximately $70 per kilowatt-hour % cheaper than conventional lithium-ion. Finally, aluminum-ion batteries deliver breakthrough performance with 380 to 400 watt-hours per kilogram, enabling super-fast charging to 100% in just 7 minutes. The Model 2 as income-generating asset. But the Model 2 isn't just about affordable transportation. Tesla is positioning it as a potential income-generating asset through the company's developing robotaxi network. With the new FSD version 14 featuring significantly improved safety metrics, the Model 2 could become the first vehicle designed from the ground up to participate in autonomous ride-hailing services. According to Tesla's latest safety report, vehicles running the new FSD system experience an accident only after approximately 6.69 million miles, while human drivers average one accident roughly every 700,000 miles. Instead of leaving the car sitting idle, the Model 2 could provide rides and generate income. Each trip could bring in $5 to $15, and if the vehicle operates 6 to 8 hours daily, it could potentially generate over $35,000 annually after expenses, essentially equivalent to an average full-time salary. With the Model 2, cheap doesn't mean basic or compromised. The low cost is absolutely real, achieved through revolutionary manufacturing processes, strategic global production, and next-generation battery technologies. But it's also fast, safe, built to last decades, and potentially capable of generating passive income for its owner. The internal code, NV91, confirms this vehicle has moved beyond concept into active development, with production expected to begin in just months. For millions of Americans waiting for an affordable electric vehicle that doesn't sacrifice quality, performance, or technology, the Model 2 represents exactly what they've been hoping for, and it's finally becoming reality.